Okay, hi everybody. My name's Thomas Monroe. I'm going to be talking about Postgres and FreeBSD together. And I got to stay on the side of the line. The strange title of my talk is some kind of attempt to capture what it felt like when I realized that you could actually hack the kernel and make useful changes to it. And after spending a lot of time writing user space code, realizing that the kernel was actually just more C code and you can hack that too. So just a little bit of background about myself. I'm pretty new to FreeBSD hacking, and Mateo Skuzik and Ellen Judah are my mentors. I've spent about 20 years working on all kinds of C and C++ stuff on many different kinds of Unix. So I'm not at all new to Unix hacking, but FreeBSD is something I took up about 3 years ago. And my main work is actually Postgres, and I work for a company called Enterprise DB, where I work on query parallelization and transaction machinery and all kinds of stuff. So one of my personal goals is to try and make FreeBSD and Postgres a really good combination. So just a quick bit of background about the way that BSD and Postgres are interlinked and their common history at Berkeley, which I think is really interesting. Michael Stonebreaker, who started the Postgres project, before that he did Ingress, and Ingress was a database that was developed at Berkeley around the time that BSD was being born, just as Ken Thompson came to Berkeley University with a suitcase full of tapes, I assume, with AT&T Unix on them, and the whole BSD thing kicked off. These database guys were taking the ideas from IBM's System R project, relational databases and so on, which ran on mainframes, and trying to do the same kind of stuff on Unix systems, these new Unix systems that were suddenly everywhere at Berkeley. So I mentioned Ingress because it has the strange honor of being the first software that was ever released entirely under a BSD license, because BSD itself was, you needed to buy an AT&T license for part of it, which cost like loads and loads of money, but Stonebreaker and his collaborators were trying to get the software they developed out of the university so that they could commercialize it on the side, and they used the BSD license to do that. And then Postgres finished up with, it was a completely new database which also used the BSD license and ran on and was developed on BSD systems. Yeah, I think that's kind of interesting. Modern Postgres runs on all kinds of Unix. The funny thing is there aren't that many kinds of Unix left, because like I can think of 3 Unixes that I worked on for years that are just gone. It's crazy, but anyway, and that was one of the reasons that I became interested in FreeBSD. I don't really want there to be one monoculture of computers remaining on Earth. So, okay, so if you work on any kind of software that has to run on many different operating systems look to you like this. They're a bunch of man pages that are essentially chiseled in stone. And that's the way the system works, and you've got to work within it. Things get much more interesting once you realize that you can actually change the operating system to make it better, and that's the case with FreeBSD. I think probably more so than other operating systems, certainly than commercial ones, and possibly more so than Linux. Some of the dilemmas that we database hackers face boil down to variations of this sort of general theme. Should the operating system do something for us, or should we do it ourselves? So that there's all kinds of scheduling problems, buffering page caches, all that kind of stuff. Should we do our own system like that? And so some of the things, I'm just going to go through a whole, to make Postgres and FreeBSD work together really well, I think there's a lot of really small things. So I'm just going to go through kind of like a whole jumble of different small topics, things that I've run into in my 3 years of using FreeBSD as my main development environment. One thing that I think is really interesting to look at is the question of buffered I/O. Postgres is basically the last major relational database to do buffered I/O, and most of the Unix operating systems developed some kind of direct I/O over the past sort of 15 years or so, and Linus Torvalds was really against it, and this was happening around about the time that DB2 and Oracle were switching to direct I/O on Linux. And that quote from the top there is from the open man page on Linux. I think they've changed it now, but there's this sort of tension between the operating system people and the database people, both of whom want to have complete control of buffering, which I think is really interesting, and we'll come back to this. So to an operating system, Postgres looks in very simple cartoon form. We use a tiny bit of System 5 shared memory, a big chunk of mmap anonymous shared memory that all the processes involved in the database cluster inherit, and we also use POSIX shared memory to run parallel queries. So I think that's quite strange to begin with. We're using all three different mechanisms for getting shared memory. We have a cluster of processes running together that are in the traditional Unix form. You have some kind of parent process. We call it the postmaster, which is forking children. So this is very classic old school Unix software, server software. And then we have a bunch of files on disk representing tables or relations and representing segments of the write-ahead log that we use to do things efficiently. The processes involved in running Postgres have a file descriptor pool. Obviously, there's a limit on how many file descriptors you can have open at once. So, and then they have this pipe that connects to the postmaster so that they can shut down quickly if they detect that the postmaster has died, if anything has gone wrong. And old versions of Postgres used to have ways of crashing that would leave all kinds of funny processes you'd have to kill if things went wrong. So this new system keeps things tidy. So that's a very simple sort of cartoon view of the operating system level objects involved. One interesting thing is that we're still using processes, and if you go back to 1989, which is close to the beginning of Postgres's creation, it was originally created in 1986, so 1989 is pretty close to that. They were saying that they used processes instead of threads because they were trying to get something going quickly. And back in those days, of course, threads worked rather differently on each operating system, so they hadn't quite. Somehow 30 years later, we still haven't quite got around to doing the threads. So from a system call point of view, what you see when you run Postgres is idle backends sit in poll, and when you run very simple queries that don't have to, where all the data that they want to use is in the Postgres page cache, buffer pool, you really just see a bunch of network operations. And when we need to pull things into our own buffer pool, so we have this buffer pool of our own, and then there's the operating system page cache. So you've got this kind of two level of buffering, and you can see data moving from the operating system page cache into Postgres's page cache with read operations. Now, one interesting thing is that when we do write operations, hopefully we just write sequential data into the write-ahead log. So you see a whole lot of writing and syncing going on in these wall files, but not on the actual data files themselves that represent tables. This is one of the tricks that databases use to go fast. And then we have this checkpointing thing which happens from time to time where data gets flushed out and written to disk, and that's where things get f-synced. I mention all of this because I'm going to be talking about some of these individual points a bit later, and I just wanted to give a very quick overview of how that looks to the operating system. Okay, so Kib, Konstantin Belousov, wrote a paper, or a descriptive sort of a report on a bunch of work that he did in 2014 when it was reported that Postgres was running really slowly on big FreeBSD systems. And that's a really interesting thing to read, and that's one of the first things I read when I started using FreeBSD for my daily development. The main story there was that in Postgres 9.3, we stopped using one gigantic System 5 shared memory region and started using an inherited anonymous shared mmap region. And for some reason that took a while for people to figure out, performance just completely tanked. And it turned out to be because that there's this sysctl where you can tell it to use physical memory for System 5 shared memory, which turns off which turns off the ability to swap it out. It just becomes physical memory. And for reasons that I don't personally understand very well, because they've mostly been fixed now, if you didn't use this option, then you get all these PV entries, and apparently there's a lot of contention on those. So systems that had lots of cores that were very busy would contend and things would go very slowly. So lots of improvements have been made since then to improve those problems. And I haven't quite figured out whether they've been entirely fixed or not. I tried to do some testing and I found that it was still possible if you tell Postgres to use the old System 5 shared memory region. You can see that there's a light blue line there which corresponds to using System 5 shared memory and using this sysctl to tell it to use physical memory for that, so it can't be paged out. I could get it to go this is on a 40 CPU Amazon image M4 X10 large. You could see that I could get a little bit more, what is that, like 5% more or something performance out of the system. I think that's kind of interesting. I need to do a bit more digging and find out if that was, a real phenomenon or not. So for that reason, we're actually going to put the ability to put System 5 shared memory back into Postgres. We took it out in 9.3. I think we're going to put it back in quite soon because it seems that there's something still here. We should probably dig into FreeBSD as well and find out if that can be fixed. Okay, so the first thing that I tried to do when I was looking for things to do on FreeBSD that would make Postgres work better, there was no fdatasync. And I tried to get this working, and I kind of had something almost working for UFS. This is fdatasync means flush the written data but not the file metadata, so things like modified time and so on. And if you're writing a whole bunch of stuff to the write-ahead log and calling fdatasync requires one random I/O instead of two because you don't have to go and change the modified time and so on. And I had something kind of working, but one day I updated my source tree and Kirk McCusick and others had suddenly implemented that, and there it was, and it was working. And that was probably a little bit too hard to start with anyway. Probably modifying the file system is probably not a good first project for learning kernel hacking. But that's something that came along in FreeBSD 11 and made Postgres faster on UFS at committing transactions, which was good. So then the next thing I tried to improve was set proc titles. So one of the things that Kib wrote about in that report was if you look at Postgres in top or in any tool, htop or anything that shows the process titles, you can see the words update and select there. You can see what each process is doing. It's got these little tags that it shows there. But if you're doing loads and loads of super fast transactions, it turns out we call that possibly tens of thousands or hundreds of thousands of times per second, or even a million times per second on some systems. And it turned out that FreeBSD was the only system that was using system calls to do that. Every other operating system that I looked at, including the other BSDs and Linux, just had a piece of memory, and you can update the process title just by writing into that memory. So I thought, well, that looks like something I could handle. So I dug into that a bit, and I found that actually the code to do it that way was still there in FreeBSD. At some point, somebody had added the system call type interface, which has some advantages and some disadvantages, but it didn't work so well when you call it 1,000,000 times a second or 100,000 times a second. So I introduced a new mode that would do it the old way, just update some piece of memory. And that has some different problems. Like in theory, you could see a torn version of half one string and half the other string. That never really happens. I mean, you don't normally write messages that are bigger than a cache line or anything anyway. So Kib convinced me to give it a different name. So you've got set proc title _fast. And the result of that was that on a 40-core machine, I could get 10% more transactions per second, which I was pretty pleased with for a very small patch, and that was the first thing I got into FreeBSD. I think there's a question of whether we should just only have that kind of set proc title. Like, do we really need the other one? I don't know, but I'm new here. I'm not going to argue that. So,
Do you need to set the title at all?
Well, it's. I think it's nice to be able to see what the system's doing. You don't need to, and you can turn that off. And in fact, the Postgres port turns it off by default. But I think that makes the experience not quite as nice as using it on other operating systems. So that's why I wanted to fix it. It's a very nice, simple way to see what the system's doing. I like it, so I don't like to turn it off. So, yeah. Okay, so the next thing I worked on was so on IRIX. originally, they were the first to do this. There's a way to ask for a signal when your parent dies. Of course, normally on any Unix system you can get a signal when a child dies, but in traditional Unix systems there was never a signal when your parent dies. I don't know why, it seems incredibly useful to me, but the IRIX people did that, and then the Linux guys copied that. I didn't just copy this from Linux, I copied it from IRIX. That's what I'm trying to say. So this was useful because I mentioned that we have this pipe between every child process and the postmaster, the parent of all these processes, because we want the whole system to shut down cleanly if somehow something bad happens to the parent process. And that means that anytime we're doing any waiting, we with like poll or select or whatever, we have that pipe there. But it also means if we're doing some kind of busy loop, and this happens mostly when you've got a streaming replica server, which is just slavishly following along, applying everything that's happening on the master server. That can be a really busy loop, and if you're never waiting, there's no efficient way to find out if the parent has died. So we finished up putting this thing where we would try and read one byte from this pipe from the parent process every time through a busy loop, which turns out to really suck. So I mean, performance-wise, somebody figured out that some streaming replica servers were spending up to 20% of their time doing that, which is completely insane. And so we got on Linux. First of all, we used set pdeathsig to get a signal instead. We just don't need to do that. If you can get a signal instead, you just never need to poll this pipe all the time. So that seemed like a reasonable thing to try and do in FreeBSD. And it was relatively simple. I mean, it's just a matter of recording in the proc struct that you would like a signal, and whenever a process exits anyway, you always have to scan through all the children to reparent them, right? So there was already a loop there, so I just had to make it deliver a signal if you asked for one. So that was a relatively simple piece of code, and that made recovery and replication immeasurably faster. Cool, and that's in FreeBSD 12. Another thing that was fixed recently, not by me, but this was a long-standing problem in FreeBSD jails, was that System 5 shared memory wasn't jailed properly, which I found kind of scary and strange. I mean, how it was like that for years apparently until FreeBSD 11. So you had to, if you were running multiple Postgres servers in different jails, you had to do some strange tricks, like you had to make sure they were using different ports or different users, because the user UID and the port appeared in shared memory in a place, and they could see each other's shared memory, which is like not what jails are supposed to do, right? So that was fixed, and so that was a good thing, and probably has good security implications for other software as well, but I don't know. Another improvement in a recent version of Postgres, we switched to using epoll on Linux, and so that should imply that we should be using KQ on FreeBSD and so on. So I wrote a patch to actually get Postgres to use KQ and KEvent to wait for things to happen, because quite often we're waiting on three FDs. We're waiting on waiting for the client to send us a query. We're also waiting on that pipe that tells us if the parent process has died, and we also have a self pipe that we need to deal with signals coming in. So we're quite often waiting for 3 file descriptors, and if you're doing that all the time with poll, you need to acquire locks on all those files, on all those objects in the kernel. So it stands to reason that if you had your own KQ file descriptor, it should be much more efficient, right? And I found that it was much faster in some cases, but in some cases it was slower. And furthermore, NetBSD users reported that it was terribly, it was much slower. And I don't know anything about NetBSD, so I didn't try to analyze that myself. Then I thought, well, if we just have this patch in Postgres that uses KQ, we could disable it for NetBSD until that can be fixed, and just use it on FreeBSD or something like that. It also goes a lot faster on Macintoshes. Not that anyone runs database servers on Macintoshes, but it was interesting to have another implementation of KQ and see that it went better. But for some reason, some workloads became slower on FreeBSD, and we still need to figure out why exactly. It seems to be something to do with the wake-up logic in the scheduler. I don't know, we need to get to the bottom of that, because in most cases, it makes things go better. So that's something that we haven't managed to get in there yet. Okay. Another thing which would be good to have in FreeBSD is sync file range. That's a system call on Linux, which is it's sort of a hint. It's not like fsync exactly. It's more like, please start writing back this range of the file. Well, it's got a few different modes actually, but the basic feature that we want is more fine-grained control over fsyncing, because we actually have a pretty good idea of when our next checkpoint is coming up, and that we have better information than the kernel does about when to write data back. So we'd like to tell it to start syncing ranges of a file that contain dirty data. That's a feature that's used by loads of different databases, so it's not just us. It would be probably quite a good idea to have that. There is a PR for it. It seems like it should be easy, but I'm still slightly frightened of hacking on file system code, so yeah. Something that happened last year in the Postgres community was what we jokingly refer to as fsync gate. Somebody figured out that a very popular operating system that isn't FreeBSD had strange semantics for fsync, in particular around error handling, that, as far as I know, almost nobody knew about. I mean, people, obviously Linux kernel hackers knew about this, but the most surprising thing was, if you call fsync and it says EIO, there was some kind of error in the IO layer, it doesn't keep your dirty buffers around anymore, it just throws them away. Which is kind of strange, because that seems to be its job, right, to not do that. So that has the strange consequence that if you call fsync again on that operating system, it can say OK, because now there are no dirty buffers, because last time it threw them away. So, and Postgres as well, but it's not just Postgres, also MySQL and MongoDB and a bunch of other software that was trying to be reliable would be prepared to retry. The way that Postgres works, it has these periodic checkpoints, and the checkpoint would fail. It would log lots of nasty error messages, but a bit later the next checkpoint would come around, and maybe after a few seconds it would try again or something like that. And then it would say success. So if you're trying to shut your database down, and when a checkpoint succeeds because it managed to fsync all the data, it then throws away the log that it could use to rescue that. You know, it's throwing away now all copies of the data. You know, this is a complete disaster, right? So one question is, are there any cases where there's an IO error, but then it fixes itself? So does retrying actually make sense at all? That's kind of an open question. Probably for a long time there weren't such cases. Probably when your disk fried, at least back in the old days, it probably didn't fix itself again. That might have been unlikely, I don't know. But now in the modern time, we've got all kinds of thin provisioning and remote storage systems, and there are transient failures. So this is a real problem. So we did the only thing we could really do, which is if you see any error from fsync, you just have to panic and just completely shut down, because the whole world is insane after that point. We have no way to know what, I mean, if people start throwing away dirty data from the kernel buffers, it's kind of game over, right? So that's what we did, and I know that the other, I know that MySQL and MongoDB made the same choice. They now panic if there's an IO error. I actually put a setting into Postgres so that you can turn that off, because FreeBSD doesn't have this problem. And there's a commit from 1999 where you can see this problem was discussed, and FreeBSD doesn't throw away pages in the page cache, the kernel's buffer, if it couldn't write it back, which makes sense. I mean, it just makes intuitive sense. The data is still dirty. Until it's been written on disk, it's dirty, right? I should add that none of this applies to ZFS, which has its own completely independent caching and so forth, and it never throws away dirty data that it hasn't written to disk. It has an option to panic or retry and so on. Yeah, so that was an interesting case where FreeBSD did very well and came out looking quite good, I think. It's also interesting to note that choice to throw away dirty data buffers when you couldn't write them back was in ancient Unix, so it was probably sort of inherited by everybody without much analysis, I think, until FreeBSD changed their mind on how that should work. Okay, so before FreeBSD 11, there was no support for collating Unicode in FreeBSD. It would be, I think it was, if you tried to do it, it would be collated in binary order or something like that. But in FreeBSD 11, there was a new collation implementation, which is shared with, I think the code came from maybe Illumos or maybe Dragonfly BSD, one or the other, but somehow those people working on those 3 projects work together. Anyone here involved in that? No. Don't want to be preaching to people who know vastly more about it than me, so double check. As of FreeBSD 11, yeah, you can actually do collations properly with Unicode, by which I mean that the stir call function in libc can compare to strings of Unicode and compare them correctly using the right rules for a given locale, for a certain language or something. And Postgres uses that a lot. We're really big on using collations because people use text in indexes, and indexes, at least B-tree indexes, are entirely based on comparisons, right? Now, because before that, FreeBSD didn't support collating Unicode, there was actually a patch in the port of Postgres for FreeBSD, which made it use ICU instead of libc, which was really interesting. Postgres itself is now slowly gaining ICU support as an option, and I'll come back to that in just a moment. So one of the problems we have with Postgres, one of the ways that we get corruption is when the collation rules change. So if you build a B tree, which is an index, it's entirely dependent on the rules not changing, the sort order for independent keys not changing. But of course they do change. They changed because there were mistakes, and they changed because all sorts of reasons. I mean, they changed because there was a case about 2 years ago where the glibc guys rolled out a new version that changed the order of a lot of German words. And all kinds of databases in Germany using the German locale had corrupted indexes. And what that meant is they couldn't see, like, their queries started giving strange answers because they couldn't find keys, because something that should be over here was now over here in the tree, whatever. It's a complicated business. It's not exactly clear what you should do about it. I mean, what a lot of commercial databases do about this is just don't use operating systems to do that. They have their own collation system, and that would be equivalent to us deciding to use. We're not going to write our own one. It's too hard, but we might use ICU from IBM to do this. But then, why should you have? Then, I mean, with my FreeBSD hat on, I don't want every application to make its own solution to collating text, because now they'll disagree with each other, which is not good. I also don't want to just give up on the problem because it's too hard. That's stupid, right? I mean, the libc provides stir call. It should work in a usable way. So what I think we should do is provide a libc interface to ask for a version string for the collation definition, and guarantee that we will change that version string so that you can compare it, and if it's not equal, then you know that the rules have changed in some way. So then at least Postgres could say, hey, this index is now corrupted, I can't use it because the collations have changed. So that's something I'm proposing right now for FreeBSD 13. And I mean, ideally I'd like to propose that to POSIX actually, and doing that requires having an implementation. So getting something like that into libc for FreeBSD would be a start to trying to convince others to accept it as well. Very simple, just a version string on collations. That's all I really want to solve that problem. I mean, you could go much further, and you could make it so that you could access the older version and make it so that.
I'm just curious, is there a way to query the version of libc?
You could do that. You can ask glibc for its version on Linux, but then whenever that changes, that might be a little bit too pessimistic. Every time libc changes, the database would have to assume that every index is now corrupted, which would be logically valid, but quite a hassle. You'd have to. So I'd like to get something that's quite fine-grained. Yeah.
Even worse, glibc sometimes change regulations in some patch in some distribution, just exported that patch to get the locale right, but didn't change the glibc version. So you're totally
Okay. Yeah. Okay. So there's all kinds of ways that could go wrong. So that's why I'd like to make a formalized way to make it work. The problem with this scheme, though, well, I've got a patch that I proposed in the review site where there's a version that gets the Unicode data that's used behind the collations. It has a version number, so we just expose that, right? The problem is that if there's a bug in the C code that reads that stuff, and we change the C code, it might change the behavior as well, and that wouldn't be captured by that. So you kind of need a combination of the library version and the data version. I'm not too sure. That's something to consider. Yeah. Okay. Another problem is that the current strcol implementation always expands the strings to a wide character format, which involves allocating memory, expanding the whole string, and then comparing them, and then freeing them, which seems to be quite wasteful. It seems like it would be quite nice to be able to do it just using the UTF-8 without having to decode the whole string. For example, you might know the answer after comparing only the first two characters, so that if you don't have to do any malloc or free, and you can exit early, then you can save a lot of time. So that's something. I know that this implementation of strcol is brand new, so I shouldn't be like beating it up. It's like really cool that we have that now. But this is something that probably not much software hammers as much as Postgres does, because we use this for any time you have an index on text, we're going to be using strcol like that. Another thing is that we have text that's not null terminated, and strcol, like all the libc functions, works with null terminated strings. That has a couple of problems. Number one, UTF-0 is actually a valid code point in Unicode, but we just can't support it in Postgres. So that's like one kind of Unicode string we can't support, which people complain about every now and then. It would be nice to fix that, but we probably can't fix that. On the other hand, we have to copy strings just to put a null that we have in some places on disk, to put a null in the end so we can call strcol, which kind of sucks. So now we're copying the string, and then we call strcol, and FreeBSD strcol is then copying the string again, and then freeing it, and then freeing. It's crazy. Like, so we need to get rid of all that stuff. So one idea I had is to have a version of strcol which has an n in the middle, and you can give it the length, and it will stop looking at bytes after, or characters after that character. I don't know whether it will be bytes or characters. I'm not sure. And actually, when I thought about that name, I tried Googling that name. I just thought, well, there could be a str-in-call, and I Googled that, and I found that Microsoft's libc has that, and I thought, well, that's kind of funny. So then I did some more Googling, and I found that it was actually in the proposal for C99, and then it was ripped out with the rationale that it's not clear what it means. Like, what if you compare two strings, and if you only compare half of the strings, that wouldn't be consistent with the longer strings order, because sometimes the rules for comparisons are hairy like that. So I don't know. Maybe there's some other kind of function name you could use to not have to null terminate things. Right. And finally, there's a thing called str transform, or it's written X form, which gives you a short binary string. It mangles your input string in such a way that the result can be compared as binary, bitwise compared with a strx formed string from some other string, and it's guaranteed to have the same result as strcol would have on the original strings. That's useful because you can take any size prefix of those, and there are some situations where you're going to do many comparisons of the same string. So if you can convert it to this form first, you can then do integer comparisons on the first 32 bits or something like that. So that enables a bunch of optimizations. However, we found when we tried to actually do this that the strx form doesn't meet the guarantee in pretty much any libc. They're all broken, at least. I mean, and that leads to corruption. So we had to turn that off, which was disappointing because it went really fast. Okay, so that's something that if we could get a reliable strx form, that would be cool. Okay, some more ideas. On AIX, they have this wonderfully named signal, sig danger. I love it. You receive sig danger. AIX, I think, was the first operating system to have overcommit. I'm not sure if it was. At least it was an early operating system to have overcommit. So the first time your program can be killed because there's not enough memory to satisfy to cache all the checks that have been written in some sense. And before it starts killing people, it will signal them. It'll signal everybody. And that gives you a small amount of time to do something about it. And Postgres, for example, could do something if it gets sig danger. It could throw away some cache data, for example, and then the system could survive. Now, it's an interesting question whether you want the system to survive or the system to die, because if you're getting sig danger on a regular basis, it's probably not really sustainable. Something's probably wrong, and you probably need to fix something. So I'm not really quite sure whether it's a good idea or a bad idea to implement sig danger on FreeBSD in order to be able to use that. But I do know that they have the same kind of concept on iOS, on Apple phones. They have, it's not exactly a signal, but something like that, where programs can clean up their caches and so on to reduce memory. And I know that the people at Facebook who do all their stuff on lots of Linux servers, they have a user space out of memory killer instead of the usual one. And they have that just so that it can tell you when it's going to kill you and you can avoid death. Should FreeBSD have a thing like that? I don't know. I think it would be interesting. It wouldn't be very hard to implement, but would it enable useful, would it actually be good for a database to do that, for example? I'm not quite sure. Moving on to the ports. So on most Linux distributions, the packages for Postgres allow parallel installation of different major versions. The major versioning scheme in Postgres corresponds to different disk formats for the data. So changing from one major version to another is a big deal because it means you have to go through a step that will modify the data on disk. And so firstly, you might want to have two major versions running at the same time for the same reason that you can install Perl 5 and Perl 6. There's certain classes of software where it's useful to have major versions installed at the same time. We should fix that in the port so you can do that. And then another thing is that in my personal opinion, this is a matter of taste, in my personal opinion, the Debian maintainers have got this, I think, the best approach to actually managing Postgres instances running on a server. They have a package called Postgres Common. It was actually written by the Debian maintainers, but it's now been taken up by various other distributions, including non-Linux things. And I think maybe we should become one of those non-Linux things that takes it up too. It lets you do it, you know the way IO cage and things like that have a nice way to list jails or whatever. It just lets you list, you've got commands like pg_ls clusters, cluster meaning an instance of Postgres. You can see them running and you can start them and stop them and create them and so on. I think if we took that code and allowed you to install multiple major versions at the same time, had this thing that could deal with them, like you can create clusters of different versions, and then we made it even better by adding ZFS knowledge and jail knowledge to it so that you could create clusters in jails and you could snapshot databases and back them up and all kinds of stuff like that using ZFS magic or integration. I think that would be really cool. And that would kind of take it to the point where, maybe it would be in a, the way people take up FreeBSD because they want to get it ZFS. If we could make it that good and like take advantage of the ZFS magic and so on with really nice tooling, it might be something that attracts people to FreeBSD because they want to run a database on it. I've only got a couple minutes left, so I'm going to go a bit faster. One thing that I ran into is that when we use POSIX shared memory, I discovered that on FreeBSD there's no way to see which POSIX shared memory segments exist. There's no way to list them, which is kind of weird. It's like someone never got around to adding the facility. I don't know, maybe it would be IPCS or some new command would show you the shared memory segments that exist. On other, for example, on Linux, their shared memory open just uses actual files on /dev/s temp file system or something. But on FreeBSD, it's in a hash table on the kernel that you cannot see. We should really fix that because it makes it quite difficult to develop with these things. You also can't see with procstat -v the names of any segments that are mapped in that way. That's something we should fix. A couple of other development hurdles I ran into. Valgrind doesn't work for Postgres. I'm not quite sure what the status of Valgrind is in the port. It aborts. It does not like running Postgres, and that's something that I would really like to. It's probably quite complicated to fix. I don't really know, but yeah. Another problem that I ran into is that dtrace ustack was just not working for a few months, but I discovered a couple of weeks ago that that's been fixed, so I crossed that off. Okay. Cloud ABI is a really interesting development for running software in a secure way. I think it will be possible to make Postgres run in Cloud ABI. That allows you to run. It's an alternative to jails and containers. It lets you run. It could let you run a database entirely trapped inside one directory, so that it can't access files outside that. Everything's based on a file descriptor, which is the root of everything it can access using capabilities. I think that would be quite an interesting thing to investigate for FreeBSD and Postgres. since I only have 12 seconds left, I'm just going to say my talk is too long for this session. Yeah, I'm going to have to. Yeah, well, I've only. I mean, recording stopped, so I'm going to. Okay, I've got a couple of minutes. Okay, so a couple of other problems that I ran into that are things we could fix. One of them is that there's this read ahead and write behind thing. Postgres quite often, if you modify a lot of rows in a table, it's reading them at one end and writing them at the other end as they fall out of its buffer, which means that you've got these two heads moving sequentially, but UFS and VFS has this single way of detecting sequential access, and it doesn't work because it's alternating between reading and writing in two different places. That's something that actually makes things go a lot slower on FreeBSD than on Linux. So we could probably fix that by increasing the smarts of the sequential access detection, the heuristics used for that. That's not a problem on ZFS or ZFS, I should say, because ZFS has its own completely separate read ahead and write ahead. Probably most people using Postgres on FreeBSD are doing it on ZFS, but certainly some use UFS as well. That's another thing we should fix. I'm going to skip that, and I'm going to skip that. And I'm going to say thank you very much for coming to my talk.